and I hope that Sergey Gorbunov from Axelar can give us a good alternative. Welcome, Sergey.
Hey everyone, great to be here and thanks so much for coming.
Doing some construction.
What? Sounds good. Let's do some construction. So before we get in there, would love to just understand a little bit about the audience. I guess curious, from everyone that's in the room, how many of you are kind of from within the Cosmos ecosystem, know different projects, know what IBC is? Can you raise your hands? All right. And for how many of you, this is like your first blockchain conference, you're just learning what the development is, you learn different ecosystems? All right, awesome, sounds great. So we have about like 30–70% mix, 30% of folks that are just learning the space. So I'll try to go a little bit slow just to give you a little bit of a sense of, what is Axelar, what are some of the key benefits, and we'll take it from there. Very high level punchline. What we're working on making secure cross-chain communication for Web3. And we have a kind of a plan and a roadmap how to get there, and I'll walk you through some of the ideas. All right. So for those of you that don't know us, we've been working on the project for a little over a year and a half. We have a team that has very deep roots in consensus, distributed systems, cryptography, many amazing engineers that worked on standardization and deploying various protocols and standards for the industry. And I think it's kind of a must if you're really trying to solve kind of cross-chain communication or interoperability, because a lot of it is very, very technical, and you have to be very, very thoughtful about how you design it and how you scale the systems. So super privileged to work with this kind of amazing team. All right, so let's kind of step back a little bit very quickly. The last decade in blockchain has been really transformational in many ways and forms. Right? We began the space in the ecosystem with a few foundational projects like Bitcoin, Ethereum. Many early applications were built around those ecosystems, but everybody quickly realized that those platforms on their own could not really scale. Right? So as a result, a number of different layer ones were developed, in 2017 to 2020 timeframe. Many of them really optimized for solving the scalability, trilemma, building a better programming environment, or just targeting specific use cases and specific markets that they were attractive to them. But only the last, I would say, kind of year and a bit, the applications are now starting to understand the need for all of these different blockchain ecosystems and trying to figure out how do I go cross-chain, how do I go multi-chain, what is going to be my long-term scaling strategy in order to provide users with the minimum transaction costs with the best user experience along the way. So lots of different applications are transitioning to these environments and figuring out how do you scale and how do you reach the global distribution of your application. And as a result, we have IBC, which is great for connecting within the Cosmos ecosystem, but mostly connectivity across different ecosystems have been dominated by various bridging ad hoc protocols. Right? The problem with most of them that you see in the market, they're centralized or they're federated, so you have a very closed or a small validator set that ensures the transactions kind of go through, but usually that validator set, is close to a federation or a small committee or just purely centralized. And as a result, you see a lot of hacks, right, and a lot of problems in the space. We've seen them over and over again over the last year. The other big problem is that most of the early generation, the kind of bridging technologies, they only provide you kind of with pairwise connectivity, right? And I'll talk more about throughout the talk today. The pairwise connectivity has a lot of actual limitations, and you have to be very careful about, how far you can take that technology, especially when it comes to cross-chain interoperability. So not a great situation we've been at. It's kind of a first-generation interoperability service. Services really increase the risks, and we've seen that over and over in the ecosystem. And that's what we really need to solve, right? This is a big fundamental problem. And some people kind of have this intuition or thinking about, well, okay, we can live in the multi-chain world, the cross-chain is hard because of all these attacks and so on and so forth, and maybe that's okay. And I think the answer is no. No matter what, everybody wants to access all the applications, all the users, all the ecosystems out there, and so you're going to need to build a secure and robust cross-chain communication protocols in order to get us to the next level of usability where anybody can interact with all of these ecosystems. And that's what really we're trying to focus on. So the core focus of Axelar is to really empower developers to pick the best platform for their needs, right? Select the smart contract language, select the finality or the cost or the gas fees, everything you need, but still being able to compose and interact with all the other ecosystems in an easy and uniform way. Okay? And so you can use the Axelar stack for secure cross-chain communication. You can do asset transfers, but more generally, you can perform arbitrary message passing and arbitrary contract calls. So it's not just limited to value transfer. You can actually transfer information and encode anything you want in that information, from NFTs and so on and so forth. And we'll talk more about that. And I think the final kind of a goal that I want to tell you that we really focus on is just simplifying the user experiences, right? I think right now, anybody you ask to get onboarded into a blockchain ecosystem, they'll play with one chain and maybe with a DEX, execute a handful of transactions, all beautiful and wonderful. Once they see another application somewhere else on a different blockchain, then they're stuck having to either move their assets or bridge or figuring out like how to use it, connect multiple wallets, pay transaction fees in multiple gas currencies. It's a very, very painful experience. Right? So a very simple goal that we're trying to get to is to allow users to interact with any asset on any application from any chain without any intermediaries in the process. Okay? This is not a problem that can be solved, in 1 month or 1 year. It requires layers of kind of stacks and protocols and services to be built around it. But this is like the end goal, and this is the ultimate, user experience that we have to work towards. In the same way as we're, interacting on the web today, packets travel across multiple networks, but we don't think about that, right? We have all these protocols that were built over the years and the services that allow us to connect and interact with a single application like Zoom or Signal or WhatsApp across all the different networks and all the different jurisdictions. And we have to work towards that, and that's what we're doing with Axelar. All right, so on a high level, the stack consists of kind of a couple different layers, and at the very top of it, you have an application layer, and really, as I mentioned earlier, our goal is to allow applications to be built on any chain. Right? From there, you can interact with Axelar different SDKs or APIs in order to communicate with all the other ecosystems. And so we have a notion of a gateway. Anybody knows about gateways in Cosmos? All right. So yes, we have a notion of a gateway. You can read and write information to the gateway, and your packets will kind of travel to any other network, and you'll be able to execute those requests and route them back to where the application is actually hosted. And underneath all of this, there's the Axelar network that runs a cross-chain gateway protocol, and this protocol is responsible for routing of information, message translation, delivery of messages, paying different relayer service fees, and so on and so forth. So that's a layer that actually gives you this permissionless and decentralized transport that you can securely rely on to validate transactions and route them to any destination that you want. All right. So what are the key ingredients behind Axelar? It really consists of, as I like to think about, 4 different components. There is a consensus layer that's based around Tendermint. And that's what allows us to actually code an arbitrary kind of functionalities to perform these cross-chain transfers. We have various finality gadgets that you can compose in order to connect a new ecosystem very efficiently. Okay, so those finality gadgets can work with proof-of-work chains to finalize the transaction when it reached a certain depth. It can also work with proof-of-stake chains where the depth is less relevant, and so on and so forth. We also have various multi-party protocols to allow the validators to kind of co-sign messages that can be relayed to different gateways and authenticated with respect to the validator signatures, right? So we support everything from multi-sig to like threshold cryptography. We'll work on like BLS implementations and so on and so forth. And finally, kind of the big important point of Axelar network is actually programmability features that are baked into the core layer itself. And programmability allows you to do multiple things, from adding a new chain, where all the requests for things like EVM chains are actually programmable on chain in the same way as adding an IBC connection. You can just type a few commands and add an IBC connection. In the same way, you can type some commands and add an EVM chain. But also you can configure things like routing paths for an asset from a source chain to a destination. You can suspend traffic if there is an attack, and so on and so forth. So this programmability at the transport layer is something really, really critical that allows you to optimize for security, optimize for routing, and add new connections in a cheap and efficient way as fast as possible. Awesome. So this is like a quick overview of a dashboard that some of our community validators have built. You can see already kind of about a dozen ecosystems being connected, everything from IBC-based chains like Osmosis and Cosmos Hub to EVM chains like Ethereum, Polygon, Avalanche, and kind of so on and so forth. And the network started to roll out a couple of months ago. We've already processed over 400 million in volume back and forth. A lot of it was actually from Terra and Luna. I think now the volume went down since the price crashed, but still a lot of traffic. I think we processed over 200,000 transactions in those couple of months. And last week was definitely quite interesting to see many people moving UST and Luna like in and out of those ecosystems. Awesome. So now I want to kind of introduce / define a brief kind of a concept of what inspired us to think about the Axelar network, right? And like what are some of the key technical design decisions that went into it? And I think one analogy that I like to make is an analogy to an overlay network. Okay. So for those of you not familiar, kind of overlay networks have been around in the networking for decades, right? What do? They allow you to more efficiently deliver information from a source to a destination than peer-to-peer connections. And what I make a point is that kind of overlay networks are actually a lot more optimal than peer-to-peer connections when it comes to interoperability for a number of reasons that I'll kind of describe in the next few slides. So what is an overlay network? Very simply, kind of simplifying some of the technical architecture decisions behind it, you can think of it as a kind of hub and spoke model that sits on top of existing consensus mechanisms. Okay, so you don't have to understand specifically how different consensus mechanisms work. It's a network that sits on top of all the other networks, and that's what sort of Axelar does at the very core of it. And it's responsible for providing these cross-chain functionalities like cross-chain asset transfer in a much more efficient, scalable, and a secure way than if everything were to be connected in a pairwise way. And I'll walk you through some of these properties in a second, but that's a key takeaway. And this is, again, the similar kind of model that we have overlay networks on the intranet. And so every time you actually browsing content or communicating with somebody, even though there is kind of an underlying peer-wise topology that messages go through, a lot of the time your traffic is actually served by one of these overlay networks like Akamai, like Cloudflare, and there's a few others that are out there. And so those are the networks that allow us to get these sub-second latencies when we fetch a content or a movie. It's not a direct connections. It's all like overlay networks, and they're all caching and all kinds of other mechanisms that give you those experiences that you're used to today. Okay, and so the core 4 properties that I want to outline that are very important for interoperability are things like universal routing, message translation, and unified security. So let me walk you through those. What I mean by universal routing, very simply, an ability to be able to onboard a new connection to a new ecosystem and automatically interconnect it with all the other previous networks. right? In one simple way. So as more connections are added, you're not adding pairwise connectivity, you're not adding fragmentation. All the other previously interconnected network can automatically communicate with any new connection that you add in. Why? Is because these overlay networks kind of understand the routing topology very effectively. They can, understand a new path has been added, and they know how to communicate with this new path without having to, synchronize across the entire world. So that's one. Two, things like message translation. So Axelar at its core already translate messages between IBC and EVM chains, for instance. Okay, so what that means is that tokens from osmosis can be transferred via IBC to Axelar, and then Axelar would translate those messages to EVM-based messages, post them on any Ethereum-based chain or EVM-based chain that you want, and vice versa. Okay. We're also extending this to more general message passing calls, so through interchain accounts, through general message passing on Axelar. As a developer, what that means is that you can really write your application, again, on any chain, communicate with any stack, let's say it's an EVM stack, but have access to all the other ecosystems through these translation layers by communicating with one simple and universal API on the chain where you actually develop your application. Okay, so you don't have to understand how does IBC actually work, right, or vice versa. You don't have to code your messages in a very complicated way, and the message translation layer helps you do that. Think about it as in any simple way as you want to communicate with somebody else. You have to do translation properties across geographic regions, across nations, and so on and so forth. And that's what Axelar does. It helps you translate these messages from different formats in a uniform and consistent way. And a final property, which is incredibly important and something we saw actually the need for over the last week with the Terra hack, is a notion of unified security. Okay. So what do I mean by this? By having this overlay network that connects all these different ecosystems allows us to actually precisely keep track of, let's say, the assets that have been moved across different connections. Right? And if one of the networks is actually compromised, then you can ensure properties at the network itself that say something like, if X dollar value has been transferred to a chain, I don't know, let me say whatever, chain Y, then no more than X can ever be transferred out of that chain. Okay? And by having the Axelar in the middle, you can enforce this rule across all the other interconnected chains without having to go and fix like pairwise connections. Right? In the pairwise world, you always will be having to deal with at the edges or across the pairwise connections that leads to quadratic blow up in just the management costs. But by having everything kind of concentrated and condensed on the network itself, you can deal with those things very efficiently, and you can enforce very strong rules that even in the case of a chain compromise, even if there has been a fork of the chain or validators have been corrupt, you know that no more value that has been bridged into that chain can ever flow out of it. Okay? If you were in the pairwise world, then enforcing these rules is kind of impossible because you always have these pairwise connections, and you have to, and you would have to enforce these rules across all of these different ecosystems. And finally, an important property is that you can actually have very strong governance rules at the network itself to, let's say, pause transfers in and out of a given chain if it gets broken. And this is something we actually had to rely on, throughout the last week when Terra was going down, and then restarting by issuing the governance, commands on the network. We can temporarily suspend the network. We don't have to, terminate the connections. We don't have to tell the validators to disconnect anything. It's actually programmable at the network layer, and so if there are compromises in the ecosystem, you can actually mitigate them quite easily. Again, doing all these things in a pairwise world where the number of connections would be quadratic would be a lot more of a management overheads, right? And it's a lot harder to orchestrate these things in a pairwise connected world. All right, awesome. So now I'll just give you like a quick sense of what are some of the functionalities you can do through the Axelar network, and everything starts with things like universal asset transfer functionality, right? Very simple. I think people have been doing this, for the last year or so. If you want to move an asset from one ecosystem to another, You can either build an application like that on top of the Axelar network or use one of the sample front ends that have been deployed. You can take an asset from any of the ecosystems, move it in and out. And the thing that we really try to optimize for here is the user experience, right? So from a user perspective, it's a single transaction that they have to submit in order to execute their transfer on the source chain, and they never have to touch or pay any relay fees, any intermediate fees like on Axelar on the destination chain, right? So all the fees are folded into the single transaction on the source chain. The user makes one click and then forgets about it. As I mentioned, everything is programmable on the chain, so we can onboard new EVM chains, we can onboard new IBC chains, and keep on adding very strong compounding effects to the network. How do you work with this? Well, there are different ways you can actually interact with this. You can get things like deposit addresses that allow users to send directly from their centralized exchange wallets or dump wallets. You actually don't have to interact with the MetaMask, which gives you a much wider distribution angle. You can also perform smart contract calls by communicating with one of the gateways that we deploy. And more general features that we actually rolled out recently are things like general message passing, right? So the basic idea here is that instead of actually passing arbitrary tokens, we want to enable users to pass arbitrary messages, right? And a message here really can be anything from a contract call to NFT transfer to a state synchronization to an Oracle request. And this allows you to kind of go from the model, let's say like a Bitcoin, where everything is about transactions of Bitcoin and like very limited script language around it, to something like Ethereum, which is more like Turing complete, where you can arbitrary code programs, you can arbitrary code messages that you want to relay from one chain to another. And so that's what this general message passing enables you to do. Very high level how it works. You have Axelar gateways. On top of it, you can write your application-specific logic in the smart contracts. And that logic can execute requests to the gateways in order to read and write messages. Okay, so and the gateways, information from the gateways is then picked up by the Axelar network and services. It gets routed and executed at the destination chain, and you don't have to think about anything else underneath it. So, and some of the early examples that we're starting to see around this general message passing are things like Web3 super apps, which I think is actually something we're going to see more and more in the ecosystem, where a lot of one-off technologies like wallets or exchanges are now entering this world where they're trying to provide more unified collections of services from a simple front end for the users, right? So for things like moving the tokens around, displaying NFTs, participating in buy and sells on various dexes. So all of this we're starting to see becoming more and more aggregated on the front ends. And with general message passing and arbitrary contract calls, you can then extend your application to support any use case that you have in mind, right? And continue building a single application with all of these different use cases without having to think about all the different software stacks that you have to support, right? It can be hosted on one chain, and messages can be routed from the home base of your application to any other application in the ecosystem and compose with one another. Like I mentioned, the use cases extend here anything from NFTs to universal AMMs, kind of cross-chain, synthetics, gaming, and so on and so forth. And I think the very interesting, again, kind of a property of this is that before, we really were thinking about moving assets to where some of these applications were, right? That's what the first generation of bridges were. Now, I think we're starting to see a lot of compute actually moving to where the assets are. Right, so instead of moving or bridging the asset, you can take a part of your program or logic, you can deliver it to where the asset is, perform some calls with respect to it, and then do state synchronization across different chains to synchronize it and agree to the state that application actually needs. So super exciting. I think it's actually a programming paradigm shift that we're going to go through over the next few years in the blockchain ecosystem, where instead of building on a single environment and having synchronous communication, you're now building in this cross-chain environment with asynchronous communication, with message passing, but that gives you a much wider distribution and much wider user acquisition capabilities. Awesome, sounds great. So that's all I wanted to mention. We do have a workshop coming up after this. One of our engineers, Fivas, is going to run you through specifically what it means to build on top of Axelar, how do you use these cross-chain general message calls and asset transfer functionalities. So I encourage you to check it out, sign up for Discord, check out the docs, and yeah, come building with that. I think it's incredibly exciting. I mean, I strongly think that we're all going to be in a world where all the chains are connected and users won't have to think about it too much. But to get there, there's still a lot of building to do. So I think we're early. Come join, and yeah, happy to take any questions.
Thank you, Sergey. We have time for one question, so I will pick the question with the most likes. For the other questions, just reach out to Sergey in the workshop room or in the hallway. So the one question with the most likes is, can you bridge to Bitcoin?
Yeah, we've been actually working on a Bitcoin module, for some time now. We had it running on the testnet for 6 months, and we're just doing some network upgrades to swap a signature scheme for it. So yeah, Bitcoin will be interconnected. It will automatically be interconnected with all the other chains. And yeah, kind of stay tuned.
Yeah, thank you, Sergey.
Thank you.